In the last episode, we had a quick look over how routing works in a Laravel app, and even added an endpoint returning some hard-coded JSON. In this episode, we'll connect to MySQL, start creating our database schema, and return actual records from a foods table. The first thing we're going to do is take a look over this database migrations folder. We use migrations to make and track changes to our database schema. Creating tables, adding or removing or modifying columns, everything is done through a migration file. Think of it as being a mini versioning control system for your database. By default, Laravel comes with two migration files, create users and create failed jobs. If we open the create users table, we see that a migration consists of two methods, the up method and the down method. The first method is executed whenever we run the migration, and the second method is executed whenever we want to roll back or reverse the migration. Basically, whatever the first method does should be reversed by the second method. If the first method creates a table, the second method should drop it. If the first method adds or modifies a column, the second method should reverse those changes. To create a new table, we use the create method on the schema class that receives two arguments, the table name and a function that is used to define the table columns. And we can call different methods like string, timestamp, IDs, decimals, integers, booleans. Laravel has a ton of methods that help us define tables, and even column modifiers like unique and nullable. In a similar fashion, we should create a migration file for our foods table. To do so, open up the terminal and enter the following artisan command. php artisan make migration create _foods_ table. If we look on the left side, we see that we now have a new migration file. We have the same create method with two default columns. In fact, there are three columns. The table ID and the timestamps creates two columns called created at and updated at. Both get filled in whenever we create or update a record. Since we are building a food tracker app, we should have the following columns. We should have a name, table, string, name, and then we should have decimals for nutritional information like carbs, fats, proteins, and calories. And then we should have the amount or some kind of measure. So it will be decimal quantity and unit of measure, which will be string. Okay, now that we have a table, we need a database to run this migration. As a database management application, I use SQL Pro. It's free, you can find it on Google and download it. I don't know any alternatives for Windows and Linux, but I assume they exist. So the first step is to create our database, which I'm gonna call food tracker. And the second step is to edit our environment file. The settings we are interested in are the DB related ones. The connection, host and port are correct. The only thing I need to change is the name of the database, which is food tracker. Username and password are also correct. I don't have any password set up. To run the migrations, we need to enter the following command, php artisan migrate. And now if we go to our database and refresh it, we see that we have the failed jobs table, users table, which were the default. We have a migration table that keeps track of what migrations were run, and the foods table. Let's add a new record so we can fetch it and return it to the API endpoint that we created here. Now that we have a foods table, we need a way to access the data inside it. To do that, we need to create a model. Models are Laravel's way of speaking with a database. They provide us with methods that allow us to query, insert, and update records without writing any SQL code. Almost every table in the database will have a corresponding model. Let's create one for our foods table. To do that, go in the terminal and type in php artisan make model and then the name of the model, which is food. Now if we go to app, let's close this, you'll see that we now have a new file called food.php, which is a class that extends an eloquent class called model. Now that we have a food model, we can query the database and return the records whenever our API endpoint is called. So if you go to foods controller, instead of returning this hard-coded JSON, we can call the all method on the food class. So we can do food all. And now if you go to our browser and refresh, we get an error, unknown database Laravel. This happened because we haven't restarted our server after modifying the environment variables. So whenever you make changes to the environment file, you need to restart your server. So if I go here, I need to restart, cancel, and run the same command. Now if I hit refresh, we get another error that says table food tracker.food doesn't exist. The reason behind this is that Laravel tries to match the plural of the model with the database table. And food is one of those words that the singular and plural form are the same. But in our case, we are referring to food as food items. So we are using foods. But we can also override that by specifying the exact table this model should connect to. We can do that by adding public table equals the name of the table, which is foods. And now if we refresh, we now get all the records from the food table, which is just one record, but if we add another one, we'll have them both. Now if we go back to the browser, refresh, we now have two foods. There's one thing we need to correct though. If we go to our routes file, which is api.php, you'll see that we have getFood/id, but we call an index method. Normally we use the index method to return a list of foods. So this ID right here should be removed, and we should create a different endpoint to get a single food item by the ID, and we usually use the show method for that. So if we go to our foods controller, we need to remove the ID from the index method and create a new method called show that will be used to fetch a single record from the database. To find a record by its ID, we can use the find method. So it's food find, and we pass in the ID. And now if we go to our browser, you'll see that food/1 will only return the milk food. So refresh, we only have this food. Food/2 will return the egg, and food/3 will return nothing. Ideally, we would want to throw a 404 error. We can do that by changing this find method with find or fail. And now if we refresh, we get a 404. Another thing we could do is, instead of fetching and returning all foods, we should probably paginate them. So we can use the paginate method. And now if we go to foods, we get paginated results. We have the data with all the foods and then metadata to help us navigate the records. And As an argument, you can also specify the number of items you want per page. So if I set 1, we will only get the first food. And then if I go to page 2, we get the second food, and so on. That's it for this lesson. In the next one, we'll see how we can create, update, and remove records from our foods table. See you next time.